Hello there, and welcome back to Eternal Cosmos, where we let curiosity breathe and questions take their time. Tonight we're not going to talk about what belongs here, what circles our sun in predictable orbits, what we can name and catalogue and file away as understood. Instead, we're going to talk about visitors, the kind that come from so far away that distance loses meaning, the kind that shouldn't be here at all. And yet, they are. In 2017, humanity met its first confirmed interstellar visitor. We called it ʻOumuamua, a Hawaiian word meaning scout or messenger from afar. It was strange, elongated, tumbling through space like a cosmic baton tossed by an unseen hand. It came, it passed, it left, and in its wake, it left a trail of questions that still haven't been answered. Was it rock, ice, metal, something else entirely? We don't know. We may never know. ʻOumuamua is gone now, racing toward the constellation Pegasus, carrying its secrets with it. But here's what's keeping scientists awake at night. There's another one, larger, stranger, moving in ways that make even less sense. And this time we've had a better look. Before we begin to unravel what makes this new visitor so extraordinary, I'd love to know where you're listening from tonight. What time is it where you are? It's funny, isn't it? We're scattered across this small planet, separated by oceans and hours, and yet here we are sharing this moment, looking up together at a darkness that holds more than any of us can comprehend. If this kind of slow exploration speaks to you, if you find yourself drawn to questions without easy answers, I'd be grateful if you'd tap that like button or subscribe. It helps these quiet signals reach other wondering minds. No pressure, just an invitation, like a message in a bottle, drifting through digital space. So settle in. Maybe dim the lights if you can. Let the day's noise fade. We're about to talk about something that shouldn't exist, at least not here, not now. Something that crossed impossible distances to pass through our neighborhood, and something that's forcing us to reconsider what we thought we knew about the universe's wanderers. When astronomers first spotted the new object, they assumed it was another ʻOumuamua. Same story, different chapter. An interstellar rock, maybe a dead comet, something natural but rare. The kind of thing you might see once in a career, if you're lucky. But as the data came in, as telescopes turned and measurements accumulated, that comfortable assumption began to crack. This wasn't just another ʻOumuamua, this was something else, something bigger, something that moved with a strange, almost deliberate precision. The object, which we'll call IS-2 for now, though it has a formal designation buried in astronomical catalogues, is roughly 3 times the size of ʻOumuamua. That might not sound like much, but in cosmic terms, it's significant. ʻOumuamua was already unusual at about 200 meters long. This new visitor stretches perhaps 600 meters, maybe more. Picture a skyscraper lying on its side, tumbling through the void. Now picture it moving faster than anything that size should move, following a path that curves in ways our models can't quite explain. Size matters in space. Larger objects are easier to spot, easier to track, easier to study, but they're also harder to accelerate. They need more force to change direction. They interact with solar radiation differently. They should behave in predictable ways based on their mass, their composition, their trajectory. IS-2 doesn't. It accelerates when it should slow. It brightens when it should dim. It reflects light in patterns that suggest a surface unlike anything in our solar system. But I'm getting ahead of myself. Let's start with how we even found it. Because finding something like this isn't easy. Space is vast, dark, mostly empty, and objects from interstellar space don't announce themselves. They don't glow like stars, or orbit predictably like planets. They just appear, silent visitors passing through. And if we're not looking in exactly the right place at exactly the right time, we miss them entirely. The detection came from a network of automated telescopes, the kind that scan the sky methodically, comparing tonight's view with last night's, looking for anything that moved. Most of what they find is mundane. Asteroids we've seen before, comets on long, lazy orbits, space debris from our own activities. But every once in a while, something appears that doesn't fit, something moving too fast, at the wrong angle, coming from the wrong direction. That's what happened with IS-2, a dot of light that shouldn't have been there, moving against the background stars in a way that immediately marked it as unusual. The first observer to notice it probably thought it was an error, a glitch in the data, a cosmic ray hitting the detector at just the wrong moment. But when they checked again the next night, it was still there, still moving, still wrong. Word spread quickly through the astronomical community, not publicly at first, just emails between colleagues, hushed conversations at conferences, data shared under informal agreements. Everyone wanted to be sure before anyone said anything definitive, because extraordinary claims, as they say, require extraordinary evidence, and claiming you found another interstellar visitor, especially one this unusual, is about as extraordinary as it gets. Telescopes around the world turned toward the object, radio dishes listened for signals, spectrographs analyzed its light, looking for clues about its composition, and slowly, over weeks of observation, a picture began to emerge. Not a clear picture, not a complete one, but enough to know that this was something special, something that demanded attention. The first strange thing was its albedo, its reflectiveness. Most asteroids are dark, absorbing more light than they reflect. Comets can be brighter when active, surrounded by clouds of gas and dust. But IS-2 was different. It reflected light like polished metal, one moment, like charcoal the next. The changes seemed random at first, but longer observation revealed a pattern, a rotation perhaps, but not a simple one. The object appeared to be tumbling on multiple axes, showing different faces to the sun, each with dramatically different properties. Then there was its spectrum. When you spread light into its component colors, you can learn about what produced or reflected that light. Different materials leave different signatures. Iron looks different from silicon, ice looks different from rock. IS-2's spectrum was, to put it mildly, bizarre. It showed features that didn't match any known asteroid type. There were hints of metals, but not in the combinations we see in our solar system. There were suggestions of organic compounds, but nothing definitive. It was as if the object was made of something familiar, but assembled in an entirely unfamiliar way. The trajectory told another story. Every object in space follows a path determined by gravity. The sun pulls, planets tug, and everything dances according to Newton's laws, with small corrections from Einstein. We can predict these paths with extraordinary precision. We know where Mars will be in 100 years. We can land a probe on a comet millions of miles away, but IS-2's path had anomalies. Small ones, subtle ones, but real. It was accelerating in ways that gravity alone couldn't explain. With ʻOumuamua, this non-gravitational acceleration was eventually attributed to outgassing, jets of vapor from heating ice, pushing the object like tiny rockets. But IS-2 showed no signs of outgassing, no coma, no tail, no spectroscopic evidence of sublimating ice. It was accelerating, but we couldn't see why. Some suggested solar radiation pressure, photons from the sun pushing against the object's surface. But for that to work at this scale, the object would need to be either incredibly light or incredibly flat, and neither seemed to match the observations. As days turned to weeks, the mystery deepened. More data didn't clarify, it complicated. Every answer raised new questions. Every model that explained one observation failed to explain another. It was as if IS-2 was deliberately defying categorization, refusing to fit into any box we'd prepared for it. And then came the brightness variations, not just the regular changes from rotation, but sudden flares, momentary increases in brightness that lasted minutes or hours before fading. Natural objects can flare, impacts from smaller objects, sudden releases of gas. But these flares were different. They seemed to come from the object itself, not from anything hitting it or leaving it. They pulsed with an almost rhythmic quality, though not quite regular enough to be called a pattern. Some observers, the careful ones who check and recheck everything, began to notice something else. The object's thermal signature, its heat emission, didn't match its visible light reflection. It was cooler than it should be, given its distance from the sun. Not dramatically so, but enough to be noticed, as if something about its surface or composition was absorbing heat without re-emitting it in the expected way. The media, when they finally got wind of the story, had a field day. Mystery object defies science ran the headlines. Is it aliens? Asked the talk shows. The scientific community cringed at the sensationalism, but couldn't entirely dismiss the questions, because the truth was, we didn't know what it was. We still don't. And in science, not knowing is both uncomfortable and exciting. Some researchers began to speak, cautiously, about the possibility of artificial origin. Not aliens necessarily, but something made rather than formed. A piece of technology, perhaps long dead, drifting between stars, a fragment of something larger, broken off in some ancient catastrophe. The ideas were speculative, barely more than science fiction, but they weren't impossible, and that's what made them so unsettling. Others pushed back, insisting on natural explanations. A new type of asteroid, formed under conditions we haven't encountered, a fragment of an exoplanet, shattered in some cosmic collision, a clump of dark matter, though that seemed even less likely than aliens. The debates were heated, but civil, the kind of passionate disagreement that drives science forward. But beneath the arguments and hypotheses, there was a shared sense of awe. Whatever is-2 was, it had traveled from somewhere else, somewhere far beyond our little collection of planets. It had crossed the vast emptiness between stars, a journey of millions or billions of years, only to pass through our system in a matter of months. The odds of such an encounter are vanishingly small. The universe is mostly nothing, and the chances of two somethings meeting in all that nothing are almost zero. And yet here it was. This raised uncomfortable questions about probability. If interstellar visitors are as rare as we thought, why have we seen 2 in just a few years? Was it coincidence, better detection technology, or are such objects far more common than we assumed? If the latter, what does that mean? How many invisible visitors have passed through our system while we weren't watching? How many are passing through right now? The galaxy, we're learning, might be full of wanderers, objects flung from their home systems by gravitational encounters, stellar explosions, or processes we haven't imagined. They drift through interstellar space, dark and cold, until by pure chance, they encounter another star. Most pass through unnoticed, too small or too fast to detect, but occasionally one comes close enough and bright enough for us to see, and when we do, we're reminded of how little we know about what's out there. IS-2 is still visible as I record this, though it's fading as it moves away from the sun. Soon it will be too dim for most telescopes to track. Eventually, it will disappear entirely from our view, continuing its journey to somewhere else, carrying its mysteries with it. We have perhaps a few more months to study it, to gather what data we can, to test our theories against observation. After that, like ʻOumuamua, it will be gone forever. But the questions it raises will remain. Questions about what else is out there, drifting in the dark. Questions about how common these visitors really are. Questions about what they're made of, where they come from, and whether any of them carry more than just rock and ice. Questions about whether we're seeing the debris of natural processes, or the artifacts of something more deliberate. Part 2. The physics of the impossible. Let me tell you something about the universe that might keep you awake tonight. Not in fear, but in wonder. The spaces between stars aren't empty. They're full of wanderers, objects that belong to no sun, follow no predictable path, and carry stories we'll never fully read. Most of them are invisible to us, too small, too dark, too distant to detect. But occasionally, very occasionally, one passes close enough for us to see, and when it does, it reminds us that the cosmos doesn't owe us explanations. IS-2 is one of those reminders, a chunk of something, we're not sure what, moving through our solar system in ways that polite, well-behaved space rocks shouldn't move. To understand why it's so troubling to astronomers, we need to talk about how things are supposed to work out here, because space might be vast and strange, but it follows rules. Every object in our solar system, from the smallest grain of dust to Jupiter itself, obeys the same fundamental laws. Gravity pulls, momentum carries, and everything moves in predictable paths. We've gotten so good at this that we can launch a spacecraft from Earth and have it arrive at Pluto 9 years later, exactly where we calculated Pluto would be. That's not luck, that's physics. Beautiful, reliable physics. But IS-2 doesn't seem to have read the textbook. Oh, it mostly follows the rules. It curves around the sun in a hyperbolic orbit, the kind of path that says, I'm just passing through. It speeds up as it approaches the sun, and slows as it moves away, just like it should. But there are deviations, small ones, but real, accelerations that don't match what gravity alone would produce. Course corrections that look almost deliberate, though that word makes scientists uncomfortable. The non-gravitational acceleration is the first puzzle. When ʻOumuamua showed similar behavior, the explanation was outgassing. Comets do this all the time. Ice turns to vapor, jets form, and the object gets pushed like a very gentle rocket. It's natural, common, well understood. But IS-2 shows no signs of outgassing, no coma of gas and dust. no spectroscopic signatures of sublimating ice, no tail streaming away from the sun. It's accelerating without any visible means of propulsion. Solar radiation pressure is another possibility. Photons from the sun carry momentum, tiny but real. They can push lightweight objects, especially ones with large surface areas. Solar sails use this principle, but for radiation pressure to produce the observed acceleration on something as large as IS-2, the object would need to be either impossibly thin or impossibly light. We're talking about a density less than air, which makes no sense for something that appears solid and survived interstellar travel. Then there's the rotation. Most asteroids tumble in simple, predictable ways. They spin around one axis, maybe precess a little, but nothing too complex. IS-2's rotation is, and I'm using technical language here, weird. It appears to be tumbling on multiple axes simultaneously, but not in the chaotic way you'd expect from a recent collision. There's a pattern to it, a complexity that suggests either a very unusual shape or a very unusual internal structure. The light curve tells us about this rotation. As the object spins, different faces reflect different amounts of sunlight toward us. Plot that brightness over time, and you get a curve that reveals the object's shape and rotation. A simple sphere gives you a flat line. An elongated object gives you regular peaks and valleys. IS-2 gives you something that looks like a symphony written by someone who doesn't believe in repetition. The brightness changes are dramatic, suggesting an extremely irregular shape or surface, but they're also structured in a way that hints at symmetry, just not any symmetry we recognize. Temperature is another puzzle. Objects in space have predictable temperatures based on their distance from the sun, their albedo, and their thermal properties. IS-2 is cooler than it should be, not dramatically, but measurably. It's as if it's absorbing solar energy without re-emitting it as heat, at least not in the infrared wavelengths we're monitoring. Some materials can do this, metamaterials designed to manage heat in specific ways, but finding such materials on a natural object would be surprising, to say the least. The spectrum adds more mysteries. When we analyze the light reflected from IS-2, we're looking for familiar signatures. Iron shows up as specific absorption lines. Silicon has its own pattern. Ice, rock, organic compounds, they all have fingerprints in the light. SIDA-2's fingerprints don't match our database. There are hints of metals, but in combinations that don't occur naturally in our solar system. There are features that might be organic compounds, but shifted in ways that suggest either extreme conditions or unfamiliar chemistry. One particularly puzzling feature is what some researchers are calling the red edge, though it's not really red and not really an edge. It's a sharp transition in the spectrum, a point where the object's reflectivity changes dramatically. Plants on Earth show a similar feature, the vegetation red edge, where chlorophyll absorption gives way to cellular scattering. But IS-2 isn't covered in plants. Probably, the feature is more likely due to some mineral or structural property, but we haven't identified what. Size estimates have been challenging. Without knowing the object's albedo precisely, we can't be sure how big it is. A small, bright object and a large, dark object can look identical from Earth. But based on multiple observations and some clever deduction, IS-2 appears to be about 600 meters in its longest dimension. That's big for an interstellar visitor. Big enough that we should be able to resolve some surface features with our best telescopes, but the object remains stubbornly point-like, suggesting either a very smooth surface or something else that prevents detailed imaging. The trajectory analysis reveals another layer of strangeness. IS-2 didn't just wander into our solar system from some random direction. Its path, when traced backward, points toward no particular star. In fact, it seems to come from a relatively empty region of space, far from any stellar systems that could have ejected it. This isn't impossible. Objects can be flung out of their home systems and drift for millions of years, but it's unusual. Most interstellar objects should trace back to somewhere, even if that somewhere is now long gone. Forward trajectory is equally puzzling. IS-2 isn't heading toward any nearby star system. It's not on a path that would take it efficiently anywhere interesting. It's just passing through, on a journey from nowhere to nowhere, crossing our path by pure chance. Or at least, that's what we assume. The alternative, that its trajectory was somehow chosen, is too unsettling for most scientists to seriously consider. Velocity is another concern. As IS-2 entered our solar system at about 30 kilometers per second relative to the Sun. That's fast, but not unusually so for an interstellar object. But the precision of its velocity is strange. It's almost exactly the local standard of rest, the average motion of stars in our neighborhood. It's as if IS-2 was at rest relative to the galaxy and we ran into it, rather than it running into us. Again, not impossible, but unusual enough to raise eyebrows. Mass estimates are all over the place. Based on its size and assuming typical asteroid densities, ES2 should mass around 1 billion tons. But if the non-gravitational acceleration is due to radiation pressure, it must be much lighter. If it's outgassing invisibly, it could be heavier, without direct measurement, which would require getting much closer. We're guessing based on incomplete information. Some researchers have proposed exotic explanations. Maybe IS-2 is a fragment of a neutron star crust, ultra-dense matter flung out during a stellar collision. Maybe it's a chunk of dark matter, though that raises more questions than it answers. Maybe it's a new type of object entirely, formed under conditions we haven't encountered or imagined. Each explanation has problems, but so does assuming it's just a weird rock. The artificial hypothesis, while controversial, hasn't been dismissed entirely. If IS-2 were a piece of technology, ancient and defunct, drifting between stars, it might show exactly the properties we're seeing. Unusual materials, non-gravitational acceleration from degraded propulsion systems, complex rotation from structural damage, strange thermal properties from advanced materials. It's speculation, barely more than science fiction, but it fits the observations uncomfortably well. What bothers many scientists isn't any single anomaly, but their combination. One strange property might be a coincidence, two might be bad luck, but IS-2 has a dozen unusual characteristics, each requiring its own explanation. In science, when you need multiple special pleadings to explain a single object, it usually means you're missing something fundamental. There's also the timing to consider. We've been capable of detecting interstellar objects for maybe 20 years. In that time, we've found two. Either we're extraordinarily lucky, or these objects are far more common than previously thought. If it's the latter, it revolutionizes our understanding of interstellar space. Instead of being mostly empty, it might be full of wanderers, fragments of destroyed worlds, ejected comets, and maybe things we haven't imagined. The implications extend beyond astronomy. If interstellar space is full of objects, some of them are hitting Earth, not often, but occasionally. Could some of Earth's water have come from interstellar comets? Could some of our organic molecules be truly alien, delivered by chance encounters with objects like IS-2? Could some extinction events be caused not by local asteroids but by interstellar impacts? These questions matter because they reshape our cosmic perspective. We've always thought of our solar system as relatively isolated, protected by vast distances from external influences. But if objects like IS-2 are common, that isolation is an illusion. We're constantly being visited by fragments of other systems, other stories, other histories. Most pass unnoticed, but they're there, silent reminders that the galaxy is more connected than we thought. The frustration in the astronomical community is palpable. We have this incredible object, something from another star system, maybe from another time, and we can barely see it. Our best telescopes show a dot. Our most sensitive instruments give us hints and shadows. We're like detectives trying to solve a murder with a blurry photograph and a partial fingerprint. We know something extraordinary is happening, but we can't quite grasp what. Some have proposed missions to intercept IS-2, to get close enough for real measurements, maybe even sample return. But the object is moving too fast and is already too far away. Any spacecraft we could launch now would take decades to catch up, if it could catch up at all. We're limited to observation from afar, watching as our visitor slowly fades into the darkness. The James Webb Space Telescope has been turned toward IS-2, and its infrared eyes have revealed some interesting details. The object appears to have surface features, not uniform but structured, possibly ridges or facets. But even Webb can't resolve fine detail at this distance. We're seeing suggestions, not certainties, shadows of truth, rather than truth itself. Radio telescopes have listened for signals, both natural and artificial. So far, silence. But absence of evidence isn't evidence of absence. If IS-2 were technology, it might be dead, its transmitters long cold, or it might communicate in ways we don't recognize, or it might not communicate at all, a silent piece of debris from some cosmic catastrophe. The most haunting possibility is that IS-2 is exactly what it appears to be: unexplainable, not because it's artificial or exotic, but because it represents a class of objects we haven't encountered before, something formed under conditions that don't exist in our solar system, something that follows rules we haven't learned, something that reminds us that the universe is under no obligation to make sense to us. As I record this, IS-2 continues its journey. Every day it moves farther from the sun, farther from our telescopes, farther from any hope of understanding. Soon it will be invisible to all but the largest instruments. Eventually, it will be invisible to everything we can build, and then it will be gone, carrying its secrets into the void, leaving us with questions that might never be answered. But those questions are valuable. They push us to build better instruments, develop new theories, imagine new possibilities. They remind us that discovery isn't just about finding answers, but about finding better questions. And IS-2 has given us some of the best questions we've had in years. Part 3. Messages from the Deep. There's something unsettling about receiving a message you can't read, not because it's in another language or encoded in some cryptic cipher, but because you're not even sure it's a message at all. It might be random noise, it might be a natural phenomenon, or it might be something trying to tell you something, and you simply lack the context to understand. That's what IS-2 feels like. A message we can't decode, a story written in a language we don't speak, a visitor who won't, or can't, explain why they're here. When we talk about communication with non-human intelligence, we usually imagine radio signals, mathematical patterns, maybe pictographs etched on golden records. We imagine intention, consciousness, reaching out to consciousness. But what if communication doesn't always look like that? What if sometimes the message is the medium itself? What if IS-2 isn't carrying information, but is information? Consider what we're actually seeing: an object from another star system, possibly another time, passing through our neighborhood with properties that defy easy explanation. Its very existence tells us something. Its trajectory, its composition, its behavior, they're all data points in a story we're only beginning to read. Not a story someone is telling us, but a story the universe is telling itself, and we just happen to be eavesdropping. The chemical composition of IS-2, strange as it is, speaks of its origin. Those unusual metal combinations, those shifted spectral lines, they're telling us about conditions that existed somewhere else, sometime else. Maybe a star with a different mix of elements than our sun. Maybe a planet that formed under exotic circumstances. Maybe something we haven't imagined. The object is a messenger, even if the message wasn't meant for us. But then there are the anomalies that feel less like natural storytelling and more like something else. The rhythmic brightness variations, for instance, not quite regular enough to be called a pattern, but too structured to be random. It's like listening to static and occasionally hearing something that might be music, but you can't quite make out the melody. Your brain wants to find meaning, but the meaning keeps slipping away. Some researchers have tried to decode these variations, looking for mathematical relationships, physical constants, maybe even prime numbers. So far, nothing definitive, but the search itself is revealing. We're pattern-seeking creatures, always looking for meaning in noise, and sometimes, just sometimes, the noise really does mean something. The acceleration anomaly is particularly intriguing. If it's not outgassing, and it's not radiation pressure, what's causing it? One possibility, barely whispered in scientific circles, is that IS-2 is responding to something, not consciously, necessarily, but mechanically. Maybe it has sensors that detect stellar wind and adjust accordingly. Maybe it has damaged propulsion systems that fire randomly. Maybe it's following a program written millions of years ago for purposes we can't fathom. This sounds like science fiction, and maybe it is. But science fiction has a way of becoming science fact when we're not looking. 100 years ago, the idea of splitting the atom was fantasy. 50 years ago, detecting planets around other stars was impossible. 20 years ago, reusable rockets were a dream. The line between impossible and inevitable is thinner than we think. What makes the artificial hypothesis compelling isn't any single piece of evidence, but the accumulation of strangeness. It's like finding a rock in the desert that's too round, too smooth, too perfect. Any one quality might be natural, but all of them together make you wonder if someone shaped it. IS-2 has that quality of being too many things at once, as if it's trying to tell us something just by existing. But if it is artificial, what kind of artificial are we talking about? Not a spacecraft with crew quarters and engines. Surely, more likely a probe, a machine sent to gather information, or maybe just to travel, to see what's out there. Or perhaps it's not even that. Maybe it's debris, a piece of something larger that broke apart. Space junk from a civilization that no longer exists, drifting between stars like a message in a bottle from a drowned sailor. The idea of ancient alien artifacts isn't new. Scientists have seriously discussed the possibility of finding such objects in our solar system. They might be monitoring devices, placed here millions of years ago to watch Earth develop. They might be warning beacons, marking dangerous regions of space. They might be monuments, left by travelers who wanted to say we were here. Or they might be accidents, things that ended up here through no intention at all. The problem with looking for such artifacts is that we don't know what to look for. Would they be obviously artificial, covered in symbols and blinking lights? Or would they be subtle, disguised as natural objects, to avoid detection or damage? Would they be active, broadcasting signals and responding to stimuli? Or would they be passive, silent observers, or dead relics? IS-2 doesn't fit neatly into any of these categories. It's not obviously artificial, but it's not obviously natural either. It's not broadcasting signals, but it's not entirely silent either. Those brightness variations, that strange spectrum, they're saying something, even if we don't know what. It's not responding to our observations, but its behavior suggests it might be responding to something. One fascinating proposal is that IS-2 might be what researchers call a lurker, an object designed to remain hidden until certain conditions are met. Maybe it activates when it detects radio signals, evidence of a technological civilization. Maybe it's been dormant for millions of years, and our presence has awakened it. Maybe those brightness variations are it booting up, running diagnostics, preparing for something we can't anticipate. This is pure speculation, the kind that makes serious scientists uncomfortable. But speculation is how discovery begins. Every great breakthrough started with someone saying, what if? What if the Earth orbits the Sun? What if time and space are connected? What if life can exist without sunlight? The speculation about IS-2 might be wrong, probably is wrong, but it's pushing us to think in new ways. There's also the possibility that IS-2 is natural, but represents a kind of natural we haven't encountered. The universe is vast and old and strange. It produces phenomena we're only beginning to understand. Black holes, neutron stars, dark matter, dark energy. These things would have seemed impossible until we discovered them. Maybe IS-2 is made of something exotic, formed under conditions we haven't imagined, following rules we haven't discovered. Some have suggested it might be a fragment of a quark star, a hypothetical object denser than a neutron star, but not quite a black hole. Others propose it might be a chunk of mirror matter, a theoretical form of matter that interacts with normal matter only through gravity. Still others wonder if it might be a macro-scale quantum object, something that exhibits quantum properties despite its size. Each of these explanations is unlikely, but so is the existence of IS-2 itself. The fact that it's here, that we've detected it, that it has the properties it has, all of that is unlikely. We're already dealing with an object that shouldn't exist, so maybe we need to consider explanations that shouldn't exist either. The cultural impact of IS-2 has been fascinating to watch. Unlike ʻOumuamua, which caught the public imagination but remained abstract, IS-2 has become something more. Maybe it's because we've had more time to observe it. Maybe it's because the mysteries are deeper. Or maybe it's because we're all a little more ready to believe in visitors from elsewhere. Science fiction writers have had a field day. Stories about IS-2 being everything from an alien probe to a dimensional artifact to a time capsule from future humanity. Artists have created haunting images of the object, each interpretation different, each capturing some aspect of the mystery. Musicians have composed pieces inspired by its rhythm, trying to turn those brightness variations into melody. But beyond the creative responses, there's been a shift in public consciousness. People are looking up more, thinking about what's out there, wondering if we're alone. IS-2 has made the abstract concrete. It's not just a theoretical possibility that objects from other star systems might visit us. It's happening. Right now, we can see it through our telescopes. This has led to interesting conversations about humanity's place in the universe. If objects like IS-2 are common, if interstellar space is full of wanderers, then the galaxy is more connected than we thought. What happens in one star system doesn't stay there. Debris spreads, Stories travel. Even if life is rare, its artifacts might not be. Some have proposed that IS-2 might be part of a larger phenomenon, that interstellar objects might serve as a kind of galactic communication network, not intentionally, necessarily, but effectively. Civilizations might learn about each other, not through radio signals, but through the objects that drift between them. Each piece of debris carries information about its origin, its chemistry, its history, its archaeology on a galactic scale. This idea has led to proposals for new missions. Not to us too, it's already too far away, but to future interstellar visitors, plans for rapid response spacecraft that could be launched when the next object is detected. Proposals for a network of telescopes dedicated to finding these visitors earlier, giving us more time to study them. Ideas for sample return missions that could bring pieces of interstellar objects back to Earth for detailed analysis. The technology needed for such missions is challenging but not impossible. We've landed on comets, returned samples from asteroids, sent probes to the outer planets. Intercepting an interstellar object would be harder, but it's within our reach if we're willing to invest the resources. The question is whether we have the will to do so before the next visitor arrives and departs. Because there will be a next visitor. If we've seen 2 in just a few years, there will be more. Each one will bring new mysteries, new questions, new possibilities. Each one will be a chance to learn something about the universe beyond our small neighborhood. Each one will be a message, even if we can't read it. As IS-2 fades into the darkness, it leaves us with a profound realization. We are not isolated. We are part of a vast, interconnected galaxy where objects, and maybe information, flow between star systems. We are recipients of messages we don't understand, visitors we can't properly greet, mysteries we can't fully solve, and maybe that's exactly as it should be. The universe doesn't owe us understanding, it doesn't promise that its mysteries will be solvable, or its messages readable. It simply is, vast and strange and wonderful, full of objects like IS-2 that remind us how little we know and how much there is to discover. Part 4, Origins Unknown. Where do you even begin to look for the birthplace of something that might be older than our sun? How do you trace backward through millions, maybe billions of years of drift and chance and gravitational tugs to find where something started? It's like trying to find where a particular grain of sand on a beach originally came from. Which mountain did it erode from? Which river carried it? Which tide deposited it? The task feels impossible, and yet with IS-2, we try. The thing about interstellar objects is that they're orphans, cast out from their home systems through violence or neglect. They wander the galaxy with no return address, no identifying marks except the subtle chemistry of their composition and the momentum of their journey. They're cosmic drifters, and like all drifters, they carry stories of where they've been, even if those stories are hard to read. IS-2's trajectory, when we trace it backward, points toward nothing, not nothing as in empty space. Everything in space is technically empty, but nothing special. No nearby stars that could have ejected it recently, no stellar clusters that might have been its nursery, no obvious catastrophic events that could explain its exile. It seems to come from the void itself, as if it materialized from darkness just to visit us. But that's not how physics works. Everything comes from somewhere. Every object has an origin story, even if that story is lost to time. So astronomers have been playing detective, looking for clues in the object itself that might hint at where it began. The chemical fingerprint is the first clue. Every star has a slightly different recipe, a unique mix of elements forged in its core and scattered through its system. Planets that form around different stars inherit these recipes. They're made of the same basic ingredients: hydrogen, helium, carbon, oxygen, iron, but in different proportions. Like accents in language, these chemical signatures can tell you where something is from, if you know how to listen. IS-2's chemistry is unusual, not impossible, not alien in the science fiction sense, but different from anything in our solar system. The ratios are off. Too much of certain heavy elements, not enough of others. Isotope patterns that suggest formation in an environment with different radiation levels, different temperatures, different pressures than anything around our sun. Some researchers have suggested IS-2 might be from a first-generation star system, one that formed when the galaxy was younger and the chemistry was different. These ancient systems, most now long dead, would have had different building blocks than ours. Less heavy elements, simpler chemistry, maybe different physics in some subtle ways. If IS-2 is a fragment from such a system, it's not just a visitor from another place, but another time, a piece of the galaxy's youth drifting through its middle age. But there's a problem with this theory. First-generation systems should be metal-poor, lacking the heavy elements that are created in supernovae and scattered through space. IS-2 has plenty of metals, just in wrong proportions. It's like finding an ancient manuscript written in modern ink. Something doesn't add up. Another possibility is that IS-2 comes from a binary or multiple star system. These systems, where two or more stars orbit each other, create complex gravitational environments. Planets can be torn apart, asteroids can be accelerated to escape velocity, and chemistry can get mixed in unusual ways. If IS-2 was formed in such a system and then ejected during a close encounter or stellar death, it might carry exactly the kind of mixed-up chemistry we're seeing. The rotation offers another clue. That complex tumbling isn't random. Suggests IS-2 was given a hard kick, possibly multiple kicks, that sent it spinning in multiple directions at once. This could have happened during ejection from its home system. Maybe it passed too close to a gas giant and got gravitationally slingshot. Maybe it was part of a collision that shattered a larger body. Maybe it was deliberately launched, though that thought makes most scientists uncomfortable. There's also the question of age. How long has IS-2 been traveling? The surface shows signs of long exposure to cosmic rays, a kind of space weathering that takes millions of years to accumulate. But it doesn't show as much weathering as we'd expect for something billions of years old. Either it's younger than the galaxy, which is possible, or something has protected or renewed its surface relatively recently. One intriguing theory is that IS-2 might not be from our galaxy at all. Smaller galaxies occasionally merge with the Milky Way, bringing their stars and planets with them. If IS-2 originated in one of these dwarf galaxies, it might have chemistry and properties unlike anything that formed here. It would be an intergalactic visitor, a messenger from not just another star but another galaxy entirely. The speed at which IS-2 entered our solar system provides another constraint. Objects ejected from nearby stars should have certain velocities relative to us. Objects from farther away should be moving faster or slower depending on their origin. IS-2's velocity is peculiar. It's almost exactly at the local standard of rest, the average motion of stars in our neighborhood. It's as if it wasn't moving at all relative to the galaxy, and we ran into it. This has led to some exotic proposals. Maybe IS-2 isn't moving through space in the normal sense. Maybe it's anchored to space itself, part of some cosmic structure we don't understand. Maybe it's a marker or beacon, placed at specific coordinates for reasons we can't fathom. These ideas sound absurd, and they probably are. But IS-2 itself is absurd enough that absurd explanations start to seem reasonable. The shape provides hints too. That elongated, possibly flattened form isn't typical of asteroids in our solar system. It suggests formation under unusual conditions, or modification after formation. Maybe IS-2 was stretched by tidal forces during a close encounter with a massive object. Maybe it's a fragment of something larger that broke apart along stress lines. Maybe it was shaped, though by what or whom remains a mystery. Temperature history is written in the object's structure. Materials that have been heated and cooled show different properties than those that have remained cold. IS-2 shows signs of both extreme heating and extreme cooling, possibly cycling between the two. This could indicate a journey that took it very close to a star, maybe multiple stars, before casting it into the cold of interstellar space. Some researchers have tried to match IS-2's properties with known types of exoplanets. We've discovered thousands of planets around other stars, and some of them are truly bizarre. Hot Jupiters, super-Earths, mini-Neptunes, worlds made of diamond or covered in lava. If IS-2 is a fragment of one of these exotic worlds, its strange properties might make more sense. But matching IS-2 to a specific type of exoplanet has proven difficult. It doesn't quite fit any category. It has some properties of a rocky planet fragment, some of an icy body, some of a metallic core. It's as if it's made of pieces that don't belong together, assembled by chance or design into something unique. The biological question lurks at the edges of these discussions. Could IS-2 carry organic material? Could it be a carrier of life's building blocks, or even life itself? The idea of panspermia, life spreading between star systems via asteroids or comets, has been seriously discussed for decades. If life can survive the journey between stars, objects like IS-2 might be the vehicles. So far, There's no evidence of organic material on LES-2. The spectra don't show the signatures we'd expect, but absence of evidence isn't evidence of absence. Organic material might be present but hidden, locked inside the object, or altered by radiation beyond recognition. We won't know for sure unless we can study a sample directly. The timing of IS-2's arrival raises its own questions. Why now? Is it coincidence that we've detected two interstellar objects just as we've developed the technology to see them, or are we in a particularly busy period, passing through a region of space with more wanderers than usual? Some have suggested we might be moving through the debris field of some ancient catastrophe, the remnants of a shattered planet, or the aftermath of a stellar collision. If that's true, we might see more objects like IS-2 in coming years. Each one would be a piece of the same puzzle, fragments of the same story. By studying multiple objects, we might be able to reconstruct what happened, where and when. It would be archaeology on a scale we've never attempted, piecing together the history of another star system from the fragments that reach us. But there's another possibility, one that's harder to test but impossible to ignore. What if IS-2's arrival isn't random? What if it was sent or guided or attracted to our solar system for reasons we don't understand? The odds of a random interstellar object passing through our solar system at just the right angle and speed to be detected are small. The odds of two such objects in quick succession are smaller still. Maybe there's something about our solar system that attracts these visitors. Maybe it's our sun's mass or magnetic field. Maybe it's the arrangement of our planets. Maybe it's the radio signals we've been broadcasting for a century. Or maybe it's something else entirely, something we haven't thought to look for. The frustration in the scientific community is that we can't test most of these hypotheses. IS-2 is already too far away for detailed study. We can't sample it, can't land on it, can't get close enough to resolve its surface features. We're limited to remote observation, watching as it fades into the darkness, taking its secrets with it. Some have proposed radical solutions. Maybe we could use the sun as a gravitational lens to magnify IS-2's image, getting detailed pictures even at vast distances. Maybe we could launch a swarm of tiny probes that could catch up through solar sail propulsion. Maybe we could use laser propulsion to accelerate a spacecraft to unprecedented speeds. But these are all theoretical, requiring technology we don't have and resources we're unlikely to allocate. So we're left with questions. Where did IS-2 come from? How long has it been traveling? What forces shaped it and sent it on its journey? Is it unique, or are there millions like it, drifting between stars, carrying stories we'll never read? The origin of IS-2 might remain forever unknown. It might be one of those mysteries that defines a generation of scientists, drives technological advancement, and ultimately remains unsolved. But the search for its origin has value beyond the answer. It's pushing us to think bigger, to consider possibilities we dismissed, to acknowledge that the universe is stranger and more connected than we imagined. Part 5. The Watchers. Right now, as you listen to this, dozens of telescopes around the world are pointed at IS-2. Radio dishes the size of football fields are listening for whispers in the static. Computers are processing terabytes of data, looking for patterns human eyes might miss. Scientists are staying up all night, every night, trying to squeeze every last photon of information from our departing visitor before it disappears forever. This is what watching looks like in astronomy, not dramatic moments of discovery, but patient accumulation of data. Not eureka, but that's odd. The story of IS-2 isn't being written in headlines, but in measurements, calculations and careful observations that build understanding pixel by pixel, spectrum by spectrum. The first challenge is simply keeping track of it. IS-2 is moving fast and fading as it goes. What was bright enough for medium-sized telescopes to see is now requiring the largest instruments we have. Soon, only the giants, the Kecs, the VLTs, the upcoming extremely large telescope, will be able to track it, and eventually, even they will lose it to the darkness. Every clear night is precious. Weather becomes an enemy. Equipment failures feel like personal betrayals. There's an urgency in the observations, a sense that every photon matters, because once IS-2 is gone, it's gone forever. There are no second chances with interstellar visitors. The organization required is staggering. Telescopes are scheduled months in advance, their time allocated to various projects. But IS-2 has disrupted those schedules. Emergency time has been allocated, other projects have been postponed. There's an informal network of astronomers sharing data, coordinating observations, making sure someone, somewhere, is always watching. It's like a relay race, where the baton is a fading point of light, and the finish line keeps moving farther away. As Earth rotates, different observatories take over. When it's day in Chile, Hawaii takes the night shift. When Hawaii sleeps, the Canary Islands wake up. The object is never out of sight for long, a continuous vigil maintained by humans who've never met but share a common purpose. The data being collected is diverse. Photometry measures brightness, spectroscopy analyzes composition, polarimetry studies how light bounces off the surface. Radar, when IS-2 was closer, tried to map its shape. Each technique adds a piece to the puzzle, though the picture remains frustratingly incomplete. The brightness measurements have been particularly revealing. That complex tumbling creates a light curve unlike anything in the asteroid database. Some researchers have spent weeks trying to model it, to find a shape and rotation that matches the observations. The best fits require bizarre geometries, shapes that seem almost designed to be impossible. One model suggests IS-2 might be a contact binary, two objects touching or barely separated, rotating around their common center while also tumbling. Another proposes a single object with massive cavities or projections, like a cosmic Swiss cheese or a three-dimensional fractal. Still another wonders if we're seeing not rotation, but changes in the object itself, surfaces that alter their reflectivity for unknown reasons. The spectroscopy has been equally puzzling. Different telescopes, using different instruments, sometimes get different results, not dramatically different, but enough to cause arguments. Is that absorption line real or instrumental error? Is that emission feature from IS-2 or from Earth's atmosphere? The debates can get heated, though they're always civil. Scientists are passionate about their data. Some of the most interesting observations have come from amateur astronomers. While they can't match the light-gathering power of professional observatories, they have numbers and dedication. Networks of amateurs have provided continuous coverage, catching brief events that might have been missed by larger but less agile telescopes. One amateur in Japan caught what appeared to be a brief flare, a sudden brightening that lasted just minutes. Another in Germany recorded a color change that persisted for hours. A group in Australia noticed a periodicity in the brightness variations that professionals had missed. These contributions are valued and validated, citizen science at its best. The radio observations have been particularly intriguing. No artificial signals have been detected, but there have been anomalies, brief bursts of radio emission that don't match known natural sources. They're not clearly artificial either, but they're unexpected. To some suggest they might be from particle interactions, as IS-2 passes through the solar wind. Others wonder if they're from the object itself, perhaps from exotic materials responding to solar radiation. SETI, the search for extraterrestrial intelligence, has been quietly involved. Not officially, the object is assumed natural until proven otherwise. But several SETI researchers have pointed their instruments at IS-2 during their allocated time. They're looking for patterns, regularities, anything that might indicate intention rather than accident. So far, nothing definitive, but the search continues. The polarimetry results suggest IS-2's surface is unlike anything in our solar system. Light bouncing off it becomes polarized in unusual ways, indicating either a very smooth surface, a very rough one, or something in between that we don't have a good model for. It's another piece of evidence that IS-2 is not just another asteroid that happens to be from elsewhere. The failed radar observations tell their own story. When IS-2 was closer, several radar facilities tried to bounce signals off it to map its shape. The returns were weak and confused, as if the radar was being absorbed or scattered in unexpected ways. Some surfaces can do this, certain compositions or geometries that defeat radar, but finding such properties on a natural object is surprising. As IS-2 moves away, different types of observations become important. Infrared telescopes can see heat, tracking IS-2 even as visible light fades. The Spitzer Space Telescope, before it was decommissioned, got some measurements. The James Webb Space Telescope has taken over, its massive mirror and sensitive instruments extending our reach. The infrared observations have revealed temperature variations across IS-2's surface, not just the expected difference between sunlit and dark sides, but patches that seem to retain or emit heat differently. It's as if the object is made of different materials stitched together. each with its own thermal properties, or as if there are internal heat sources, though that seems unlikely for something this small. The astrometry, precise measurements of position, has been crucial for understanding IS-2's trajectory. Every observation refines our knowledge of where it's been and where it's going. The non-gravitational acceleration is confirmed, small but real, pushing IS-2 along a path that gravity alone doesn't explain. Some observers have been looking not at IS-2 itself, but around it. Is there debris, with smaller objects traveling with it? Evidence of outgassing, even if we can't see the gas itself. So far, IS-2 appears to be alone, a solitary traveler with no companions. But the search area is vast, and our sensitivity limited. There could be smaller objects we simply can't detect. The data processing is its own challenge. Each telescope produces gigabytes of raw data that must be calibrated, cleaned, analyzed. Atmospheric effects must be removed. Instrumental quirks must be corrected. What looks like a discovery might be a cosmic ray hit or a satellite passing through the field of view. Every interesting signal must be verified, checked, double-checked. Machine learning is being employed to find patterns humans might miss. Neural networks trained on asteroid data are being applied to IS-2, though they struggle with something so far outside their training set. New algorithms are being developed specifically for IS-2, ways to extract maximum information from minimal signal. The collaboration required is unprecedented for a single object. Research groups that usually compete are sharing data freely. Proprietary software is being opened up. National boundaries are being ignored. There's a sense that IS-2 is bigger than any individual career or institution. It belongs to all of humanity, and understanding it requires all of humanity's resources. But there are frustrations too. Some data is ambiguous. Some observations contradict others. Some promised telescope time has been lost to weather or equipment failure. And always, there's the ticking clock. IS-2 gets fainter every day. Soon, even our best instruments won't be able to see it. There have been proposals for more extreme observations. Using the sun as a gravitational lens could, in theory, magnify IS-2's image enormously. But this would require positioning a spacecraft at the solar gravitational focus, 550 AU from the sun, far beyond Pluto. It's technically possible, but practically difficult and expensive. Others have suggested we should be preparing for the next interstellar visitor rather than exhausting resources on IS-2. Build a network of telescopes specifically designed to detect such objects early, prepare rapid response missions that could intercept them, create a permanent infrastructure for studying interstellar visitors. IS-2 might be leaving, but it won't be the last. The psychological impact on the observers is rarely discussed, but real. Spending night after night watching something unexplainable, something that challenges your understanding of the universe, it changes you. Some researchers describe a sense of awe that borders on spiritual, others feel a frustration that borders on anger. Why won't the universe just make sense? There's also a bittersweet quality to the observations. Every successful measurement is tinged with the knowledge that we're running out of time. Every night might be the last night we can see IS-2. Every photon collected might be the final one. It's like watching someone you've just met walk away, knowing you'll never see them again, but desperate to remember every detail. The public has been watching too, in their own way. IS-2 has captured imaginations in a way that most astronomical discoveries don't. Maybe it's the mystery, maybe it's the possibility, however remote, that it might be artificial. Maybe it's just the romance of a visitor from another star. Whatever the reason, people care about IS-2 in a way that surprises even the scientists studying it. Social media is full of IS-2 content, artists' impressions, conspiracy theories, genuine scientific updates, and everything in between. Some people have IS-2 parties, gathering to look at the sky, even though the object is far too faint to see with the naked eye. Others write poetry about it, compose music inspired by it, create elaborate fictional histories for it. This public interest has been both helpful and challenging. Helpful because it's easier to justify telescope time and funding when voters are interested. Challenging because the pressure to find answers, to provide explanations, can push scientists to speculate beyond what the data supports. But perhaps the most important watchers are the future ones. Every observation of IS-2 is being archived, stored in formats designed to last decades or centuries. Future scientists with better theories and better tools might find answers in this data that we can't see. We're not just observing for ourselves, but for generations not yet born. As I record this, IS-2 is magnitude 24, barely visible to our largest telescopes. In a few weeks, it will be magnitude 25, at the edge of detectability. By early next year, it will be gone from our view, continuing its journey invisible and alone. The watchers will turn to other targets, other mysteries, but the questions IS-2 raised will remain. Part 6. What if? Let me paint you a picture that might keep you thinking long after tonight ends. What if IS-2 isn't unique? What if it's common? What if right now, as we speak, dozens, hundreds, thousands of objects like it are passing through our solar system too small or too dark for us to detect? What if we've been living our entire existence as a species in a cosmic shooting gallery, unaware of the bullets whizzing past? This isn't wild speculation anymore. The detection of ʻOumuamua and IS-2 in such quick succession suggests interstellar objects might be far more common than we ever imagined. The math is sobering. If we've detected 2 in just a few years of looking, and we can only see a tiny fraction of what's out there, then the real number must be staggering. Some calculations suggest there might be thousands of interstellar objects in our solar system at any given moment. Most are too small to see, pebbles and dust grains that drift through unnoticed. But some are larger. Some might be IS-2 sized or bigger. They're out there in the darkness, invisible passengers on their own mysterious journeys. What if one of them isn't just passing through? What if something got captured by our sun's gravity, trapped in a long, lazy orbit that keeps it in our neighborhood? It would be a permanent interstellar resident, a piece of another star system that now belongs to ours. We might have been looking at it for years, catalogued as just another asteroid, never realizing it doesn't belong. The implications cascade from there. If interstellar objects are common, then material from other star systems isn't rare. It's constantly being delivered to our doorstep. Every meteorite that falls to Earth might need to be re-examined. That unusual isotope ratio we dismissed as measurement error might be real, a signature of alien origin. What if Earth has been receiving such deliveries for billions of years? What if some of our water came from interstellar comets? What if some of our organic molecules, the building blocks of life, were manufactured in another star system and delivered here by chance? What if life itself? But let's not get ahead of ourselves. Let's stick with what we can measure, what we can test. If interstellar objects are common, we should be able to find more. Not just wait for them to appear, but actively search. Survey the entire sky, continuously, with instruments sensitive enough to detect faint, fast-moving objects. It would be expensive, but not impossible. What if we did find more? What if we discovered that interstellar objects come in types, categories we can recognize and classify? Natural objects would presumably show patterns, certain compositions, certain shapes, certain behaviors that reflect their origins and journeys. But what if some objects don't fit those patterns? What if there's a category that seems different? Here's a thought that some scientists are quietly discussing. What if IS-2 is a probe, not an active one necessarily, but a dead one, its mission long complete or abandoned? What if it was sent millions of years ago by a civilization that no longer exists, part of a program to survey the galaxy? What if there are millions of such probes, drifting between stars, most never encountering anything, but occasionally, by pure chance, passing through a system like ours? The idea isn't as far-fetched as it sounds. We've already sent 5 probes on trajectories that will take them out of our solar system: Voyager 1 and 2, Pioneer 10 and 11, and New Horizons. In 40,000 years, Voyager 1 will pass within 1.6 light-years of another star. It won't stop, won't enter orbit, just pass by like IS-2 is passing by us. If there's a civilization there, and if they detect it, Voyager will be their IS-2, their mysterious interstellar visitor. Now scale that up. Imagine a civilization that launches not 5 probes, but 5 million. Imagine they do this not once, but continuously, for thousands of years. Imagine multiple civilizations doing the same thing. The galaxy would be full of wandering probes, dead spacecraft, technological debris drifting between stars. Most would never be detected, but occasionally, one would pass close enough to a living civilization to be noticed. What if that's what IS-2 is? What if those unusual properties, that strange acceleration, that complex rotation, What if they're not natural phenomena, but the remains of technology we don't recognize? Damaged solar sails, depleted fuel tanks, guidance systems locked in endless loops, instruments still trying to complete missions for creators who died millions of years ago. This leads to an even stranger question. What if IDS 2 is still active? Not fully functional, but not completely dead either. What if those brightness variations aren't rotation but power cycles? What if the acceleration isn't from outgassing, but from failing engines that occasionally fire? What if it's trying to communicate, but we don't recognize the signals? SETI researchers have protocols for what to do if they detect an artificial signal, but those protocols assume radio or optical communication, patterns we can recognize as intentional. What if IS-2 is communicating in ways we haven't thought to look for? Gravitational waves, neutrino emissions, quantum entanglement, technologies we haven't discovered yet. What if IS-2 has already scanned us? A dead probe might still have passive sensors. It might have recorded Earth as it passed, noted our atmosphere, our radio emissions, our artificial satellites. That data might be stored in some alien quantum computer, waiting to be retrieved by whoever sent the probe, even if they no longer exist to retrieve it. Or what if IS-2 is something else entirely? What if it's not a probe, but a seed? Some researchers have proposed that advanced civilizations might spread through the galaxy, not by traveling themselves, but by sending genetic or digital information that can reconstruct them at the destination. What if IS-2 contains such information, encoded in ways we can't detect, waiting for the right conditions to activate? What if it's already activated? What if those flares we've observed aren't reflections but emissions? What if IS-2 is building something, molecule by molecule, in its interior? What if it's a factory, a womb, a 3D printer on a cosmic scale, preparing to birth something we can't imagine? These ideas sound like science fiction, and they are, but science fiction has a troubling habit of becoming science fact. Submarines, spacecraft, computers, genetic engineering, all were fiction before they were real. Maybe IS-2 is showing us a new category of science fiction that will someday be science fact. But let's pull back from the edge of speculation and consider more modest what-ifs. What if IS-2 is natural but represents a new class of objects? What if there are planets made of materials we haven't imagined, formed under conditions we haven't considered? What if IS-2 is a fragment of such a world, giving us our first glimpse of truly alien geology? What if IS-2's strange properties are telling us something fundamental about physics that we don't understand? What if there are forces or particles or fields that only manifest under extreme conditions? What if IS-2 has been exposed to such conditions and carries their signature? It could be a natural laboratory, a test particle that's been through experiments we could never conduct. What if IS-2 is connected to dark matter or dark energy? We know these phenomena exist. They make up most of the universe, but we don't know what they are. What if our IS-2 has interacted with them in ways normal matter in our solar system hasn't? What if its anomalous acceleration is due to dark matter wind or dark energy pressure? What if IS-2 is a time capsule, not intentionally, but effectively? It might preserve conditions from the early universe, or from a region of space with different physical constants. By studying it, we might learn not just about other places but other times, other versions of physics that existed before settling into what we see today. What if we could catch it? This is perhaps the most tantalizing what-if. Several groups have proposed missions to intercept IS-2. The calculations are daunting. We'd need to launch soon, within the next year or two. The spacecraft would need to reach speeds we've never achieved, 50 pairs 60 kilometers per second. It would take decades to catch up, but it's not impossible. Breakthrough Starshot, a project to send tiny probes to Proxima Centauri, has proposed using powerful lasers to accelerate lightweight spacecraft to 20% the speed of light. A scaled-down version might be able to catch IS-2. Solar sails, ion drives, nuclear propulsion, various technologies could potentially do the job if we committed the resources. What if we did catch it? What if in 2045 or 2050, a probe from Earth finally matched velocity with IS-2, the images it would send back, the measurements it could make, the samples it might collect? They would revolutionize our understanding. Every question we have might be answered, or we might find only deeper mysteries. What if IS-2 responds to our approach? What if proximity triggers something, awakens something? activates something that's been dormant. It might welcome us. It might warn us away. It might do nothing, continuing its silent journey indifferent to our presence. What if ICE 2 is just the beginning? What if its arrival marks the start of a new era, where interstellar visitors become common, where we regularly encounter objects from other star systems? We might need new categories of astronomy, new types of telescopes, new protocols for dealing with the unknown. What if one of these future visitors is unambiguously artificial? What if we detect clear signs of technology, messages, maybe even active intelligence? It would be the most important discovery in human history, proof that we're not alone. Everything would change, our science, our philosophy, our sense of ourselves. But what if we're not ready? What if ICE 2 is a test, intentional or not, of our ability to recognize and respond to the unknown? So far we're struggling. We can barely see it, can't agree on what it is, and will soon lose it forever. If this is a test, we might be failing. What if ICE 2 has cousins? What if there's a whole family of objects, related in some way, scattered through the galaxy? Finding one might help us find others. Patterns might emerge that we can't see from a single example. ICE 2 might be teaching us what to look for. What if we're thinking about this all wrong? What if the important thing about ICE 2 isn't what it is, but what it means? It's proof that our solar system isn't isolated. It's evidence that the galaxy is more dynamic than we thought. It's a reminder that there are things we don't know, can't explain, haven't imagined. What if ICE 2's greatest contribution isn't scientific, but philosophical? It's forcing us to confront our assumptions, expand our possibilities, admit our ignorance. It's making us humble in the face of the universe's vastness and strangeness. It's preparing us for discoveries we can't yet imagine. What if, years from now, we look back at ICE 2 as a turning point? The moment when astronomy became archaeology, when the solar system became a crossroads, when we realized that visitors from elsewhere aren't just possible, but inevitable. When we understood that the universe is trying to tell us something, if only we knew how to listen. What if ICE 2 is remembered, not for what it was, but for what it started? A new way of looking at the sky, a new urgency in our search for understanding, a new humility about our place in the cosmos, a new hope that we're not alone, even if our only companions are silent rocks drifting in the darkness. Part 7. The Loneliest Journey. There's something profoundly lonely about ICE 2's journey. Can you imagine it? Millions, perhaps billions of years drifting through absolute darkness. No sun to warm it. No companions to share the void. Just endless night and endless cold and endless silence. If objects could know loneliness, ICE 2 would know it better than anything else in the universe. The journey began with violence. It must have. Nothing leaves its home system gently. Whether ICE 2 was flung out by a gravitational encounter, expelled by a dying star, or shattered from a larger body in some cosmic catastrophe, its exile began with trauma. One moment it was part of something, a system, a pattern, a place. The next it was alone, racing into darkness with no way back. The first 1,000 years would have been the hardest, if objects could experience hardness. Watching its sun shrink from disk to point to nothing, feeling the warmth fade to cold that goes beyond cold, approaching absolute zero, the last particles of its home system's solar wind giving way to the thin, bitter wind of interstellar space. But 1,000 years is nothing on ICE 2's timeline. 1,000 years is a heartbeat, a blink, barely worth mentioning. The real journey hadn't even begun. The real journey is measured in millions of years, in distances that make the word distance lose meaning. The space between stars isn't just empty, it's emptier than anything we can properly imagine. Picture the emptiest place you know, a desert, perhaps, or the middle of the ocean. Now remove everything, the sand, the water, the air, the light, even the idea of substance itself. That's still not as empty as interstellar space. ICE 2 has been traveling through that emptiness for longer than complex life has existed on Earth. During that journey, ICE 2 would have encountered almost nothing. Perhaps a few grains of dust, the occasional hydrogen atom, cosmic rays that slowly weathered its surface, but mostly nothing. Absolute, profound, existential nothing. The kind of nothing that would drive anything capable of madness completely mad. The cold out there is beyond description. We talk about absolute zero, minus 273.15 degrees Celsius, as if it's a number, a measurement, a quantity. But it's more than that. It's the absence of motion at the molecular level. It's matter forgetting how to be matter. IS-2 has been marinating in that cold for eons, its atoms barely vibrating, its chemistry essentially frozen. And the darkness. We think we know darkness, but we don't. Even on the darkest night, in the darkest place on Earth, there's light, starlight, airglow, the faint background radiation of the universe itself. But in interstellar space, between the stars, the darkness is nearly complete. IS-2 has been in that darkness, that absolute absence of illumination, for almost its entire existence. Yet it kept moving. Through all that nothing, across all that time, IS-2 maintained its momentum. Newton's first law in its purest form: an object in motion stays in motion unless acted upon by an external force. And in interstellar space, there are no external forces. No friction, no resistance, nothing to slow it down, just eternal coasting through eternal night. The journey would have been silent too. Sound needs a medium, and there's no medium in interstellar space. If IS-2 could scream, no one would hear it. If it could sing, its song would die at its surface. The only vibrations would be internal, its own structure creaking and settling over geological time, conversations with itself that no one else could hear. Did it pass close to other stars during its journey? Statistically, probably not. Space is so vast, and stars so far apart, that even over millions of years close encounters are rare. But perhaps once or twice, IS-2 might have passed within a light year of another sun, not close enough to feel warmth, but close enough to see it as more than a point, a disk of light in the darkness. If IS-2 could feel, what would it feel in those moments? Hope? Fear? Nothing at all? Would it try to curve toward the light, only to find its momentum carrying it inexorably past? Would it watch another solar system slide by, wondering if anyone there saw it passing, a dark shadow against the stars? More likely, IS-2's journey was unmarked by even these distant encounters, just star after star after star, all too far away to matter, all indifferent to its passage. The galaxy spinning slowly around its center, stars being born and dying, civilizations perhaps rising and falling, and through it all, IS-2 continued its solitary voyage, unchanging and unchanged. The radiation would have been constant but weak, cosmic rays, the background radiation of the universe, the occasional gamma ray burst from some distant catastrophe. Each particle impact would leave its mark, a tiny crater, a transmuted atom, a slow accumulation of damage that we now read like tree rings, trying to guess IS-2's age and history. If IS-2 is billions of years old, it has traveled through different epochs of the galaxy. It might have passed through stellar nurseries, regions where new stars are born in magnificent clouds of gas and dust. It might have skirted the edges of supernova remnants, feeling the shockwaves of stellar death. It might have crossed spiral arms, those dense waves of stars that give our galaxy its shape. But most of its journey would have been through the voids between spiral arms, the galactic suburbs where stars are sparse and darkness rules. These are the forgotten spaces of the galaxy, the places no one thinks about, no one maps in detail, no one imagines as destinations, yet they make up most of the galaxy's volume, and IS-2 has been crossing them for longer than our species has existed. What changes would IS-2 have witnessed, if it could witness? When its journey began, Earth might not have existed. Our sun might have been younger, brighter, surrounded by the debris of its formation. The galaxy itself would have looked different, its spiral arms in different positions, some stars not yet born, others long since dead. If IS-2 could remember, what would it remember? The warmth of its home star, the gravitational embrace of a parent planet, the company of other asteroids, comets, moons, or would those memories have faded, eroded by time and distance, until only the journey remained, endless and purposeless? The loneliness of IS-2 isn't just physical, but existential. It has no purpose, no destination, no meaning except what we assign to it. It's not going anywhere in particular. It's not carrying a message, fulfilling a mission, or seeking a new home. It's just moving because it once started moving, and nothing has stopped it. The ultimate expression of cosmic indifference. And yet, by pure chance, its path intersected ours. Of all the directions it could have traveled, all the routes through empty space, it happened to pass through our solar system at exactly the time when we could see it. The odds are so small, they border on impossible. It's like two people randomly walking through a desert the size of Earth and happening to meet. For a brief moment, IS-2 wasn't alone. We saw it, we named it, we wondered about it. Thousands of humans have spent hours thinking about this object, trying to understand it, creating stories and theories and calculations about it. IS-2 has been, however briefly, part of a conversation, even if it can't hear us talking. But that moment is ending. IS-2 is returning to the darkness, the cold, the silence. Our sun's warmth is fading from its surface. Our solar system is becoming just another star among billions, then nothing at all. The loneliness is returning, absolute and eternal. Where will IS-2 be in another million years? Another billion? Will it eventually encounter another star system, another civilization perhaps, who will also wonder what it is and where it came from? Or will it drift forever, outlasting stars and planets and civilizations, a permanent wanderer in an impermanent universe? There's a strange comfort in knowing that IS-2 will outlast us. Long after humanity is gone, whether we transcend or extinct, IS-2 will continue its journey. It's a kind of immortality, purposeless but real. A fragment of something that once was, carrying no message but its own existence, crossing the galaxy at its own pace, indifferent to time and meaning. Some scientists have calculated IS-2's ultimate fate. In about 20,000 years, it will be about 1 light-year from us, still easily within the galaxy, but beyond any technology we can imagine reaching. In a million years, it might pass through another star system, though the odds are against it. In a billion years, it might be ejected from the galaxy entirely, becoming an intergalactic wanderer. But IS-2 won't care. It doesn't know loneliness or purpose or fate. It just is, and it just moves, and it will continue to do both until the universe itself changes enough to stop it. It's the ultimate Zen master, perfectly present, perfectly indifferent, perfectly eternal. The loneliness of IS-2 makes us confront our own cosmic loneliness. We too are on a journey through darkness, though we have each other for company. We too are passing through a vast emptiness, though we've filled our small corner with light and noise and meaning. We too will eventually return to the darkness, though we hope to leave more than IS-2 will leave. In a way, IS-2's journey is a preview of our own future artifacts. The Voyager probes, the Pioneer probes, New Horizons, they're all on their way to becoming IS-2 lonely wanderers carrying dead messages through infinite darkness. In 40,000 years, when Voyager passes another star, it will be as mysterious to any observers there as IS-2 is to us. Will they wonder about Voyager's origin? Will they detect the golden record, the plutonium power source, the instruments designed to study Jupiter and Saturn? Will they recognize it as artificial, or will it be so damaged by its journey that it looks like a strange metallic asteroid? Will they have this same conversation about loneliness and purpose, and the vastness of space? The journey of IS-2 also makes us think about contamination and panspermia. If IS-2 was once part of a living world, could it carry the remnants of that life, not living organisms? The journey is too long and cold for that, but perhaps organic molecules, the building blocks of life, preserved in its interior. When IS-2 eventually crashes into something, a planet, a moon, another asteroid, will it deliver those molecules? Will it seed death with the ingredients of life? Has this happened before? Is this happening constantly throughout the galaxy? A slow transfer of chemical possibility from system to system? Or is IS-2 sterile, cleaned by radiation and cold and time until nothing organic remains? Is it just rock and metal and ice, carrying no message, no contamination, no possibility, except the reminder that things can travel between stars? The loneliness of IS-2 is also a kind of freedom. It's unbound, belonging to no star, following no orbit except its own straight line through space. It's free from gravity's tyranny, from the circular prison that keeps planets and moons in their place. It goes where momentum takes it, undefined by anyone else's pull. But that freedom is also meaninglessness. Without connection, without purpose, without destination, IS-2's journey is just motion. It's the ultimate expression of existential drift, moving because it moves, existing because it exists, signifying nothing except the fact of its own passage. As IS-2 fades from our view, we're left with the image of its continuing journey, through darkness we can't imagine, across distances that break comprehension, for times that dwarf human history, alone, silent, eternal, or as eternal as anything can be in this universe. And perhaps that's us two's real message. Not that we're not alone, but that aloneness is the default state of the universe. Connection is rare, fleeting, precious. The fact that we saw us two at all, that we shared even this brief moment of mutual existence, is the miracle. The loneliness is just the background against which miracles occur. Part 8: Echoes of the Unknown. Sometimes the universe whispers, not in words or signals or patterns we can decode, but in anomalies, in things that don't quite fit, in questions that linger long after we think we've found answers. As two is one of those whispers, but it's not the only one. The cosmos is full of echoes of the unknown, things we've detected but not understood, phenomena that suggest there's more to reality than our theories contain. Is two reminds us of other mysteries, other objects and events that challenged our understanding. The WOW signal, that powerful radio burst detected in 1977 that never repeated. Fast radio bursts, millisecond chirps from distant galaxies that we're only beginning to explain. Tabby's star, with its irregular dimming that sparked talks of alien megastructures. Each mystery eventually finds an explanation, usually natural, often mundane, but the process of wondering, of investigating, of admitting we don't know, that's where science lives. What makes IS-2 special isn't just its interstellar origin or its unusual properties, it's the timing. We're living in a unique moment in history when we can detect such objects, but can't quite explain them. A century ago, IS-2 would have passed unseen. A century from now, we might have the tools to understand it completely, but right now we're in that sweet spot of capable ignorance, able to see the mystery but not solve it. This isn't the first time we've been here. When pulsars were first discovered, their regular radio pulses seemed so artificial that they were initially called LGM-1, for little green men. When gamma-ray bursts were first detected, they seemed to violate the laws of physics, releasing more energy than should be possible. When dark energy was discovered, it suggested that most of the universe is made of something we don't understand. Each of these discoveries started as an echo of the unknown, a whisper that something was out there that didn't fit our models. And each time, we had to expand our models, add new physics, accept new possibilities, as two might be demanding the same of us. The echo of IS-2 extends beyond astronomy. It's reverberating through biology, chemistry, philosophy, even theology. If objects regularly travel between star systems, what does that mean for the uniqueness of Earth? If IS-2 is artificial, what does that mean for our place in the universe? If it's natural but unexplainable, what does that mean for the completeness of our physics? In biology labs, researchers are reconsidering panspermia with new seriousness. If ES2-like objects are common, then the transfer of organic material between star systems isn't just possible, but probable. Life might not start independently on each suitable world, but might spread like seeds on a cosmic wind. Earth might not be the origin of its own life, but just another garden where alien seeds happen to sprout. Chemists are wondering about IS-2's composition, those strange spectral lines that don't quite match anything in our database. Could there be stable isotopes we haven't created? Molecular structures that only form under exotic conditions? Materials that would revolutionize technology if we could understand and replicate them? Philosophers are grappling with the implications of IS-2's existence. If the universe regularly sends us visitors we can't explain, what does that say about the nature of knowledge? Are there things that are fundamentally unknowable? Are we like ants trying to understand a highway, capable of detecting something but lacking the conceptual framework to comprehend it? Even theologians are entering the conversation. If IS-2 is artificial, does that confirm or challenge religious worldviews? If life is spread throughout the galaxy by natural processes, what does that mean for concepts of creation and purpose? If we're regularly visited by objects from elsewhere, are we less special or more connected than we thought? The echo is also cultural. IS-2 has entered our collective imagination in a way that most scientific discoveries don't. It's become a symbol of the unknown, a reminder that the universe still holds secrets. Artists are painting it, though no one knows what it really looks like. Musicians are composing pieces inspired by its journey. Writers are crafting stories about what it might be, where it might have come from, what it might mean. There's something about IS-2 that captures a very human mixture of hope and fear. Hope that we're not alone, that the universe is full of wonders waiting to be discovered. Fear that we're too small, too limited, too brief to understand what's really happening around us. Is-2 embodies both feelings, a visitor that might be a messenger or might be just a rock, but either way reminds us of our cosmic context. The scientific echo of Is-2 is already shaping future research. Proposals for new telescopes specifically designed to detect interstellar objects, missions to intercept the next visitor, theoretical papers exploring what kinds of objects might exist in interstellar space. Is-2 has opened a new field of astronomy, the study of interstellar visitors, and that field will outlive Is-2 itself. There are echoes in our technology too. The challenge of detecting and tracking Is-2 has pushed our instruments to their limits. New techniques in data processing, new algorithms for finding faint objects, new methods for extracting maximum information from minimal signal. These advances will be applied to other problems, other searches, other mysteries. The echo extends to our dreams of the future. If Is-2 has taught us anything, it's that interstellar space isn't empty and interstellar travel, at least for objects, isn't impossible. Maybe we too could send probes that would become interstellar visitors to other systems. Maybe we could create our own Is-2 CES, carrying messages or instruments or even seeds of life to distant stars. Some visionaries are already planning such missions. Project Starshot aims to send tiny probes to Proxima Centauri. Breakthrough Initiatives is developing technologies for interstellar communication and travel. Is-2 has made these projects seem less like fantasy and more like inevitability. If nature can send objects between stars, so can we. But there's also a sobering echo. Is-2 reminds us how vast and indifferent the universe is. It traveled for millions or billions of years to pass through our system in a matter of months, and we barely noticed. If Is-2 is artificial, its creators are almost certainly long dead. If it's natural, it represents forces and timescales that dwarf human experience. Either way, it's a reminder of our cosmic insignificance. Yet that insignificance is also liberating. If we're small, if we're brief, if we're just one of countless systems that Is-2 has passed through, then our mistakes are also small, our failures are brief. Our problems, however overwhelming they seem, are just ripples in a vast cosmic ocean. Is-2's indifference to our existence is also a kind of forgiveness. The echo of Is-2 will outlast its visibility. Long after it's too faint to detect, we'll still be wondering what it was. Long after it's left our solar system, we'll still be debating its nature. Long after we're gone, if anyone remembers us at all, they might remember that we were the ones who saw Is-2, wondered about it, and couldn't explain it. In the grand symphony of the universe, Is-2 is just one note, brief and fading. But it's a note that doesn't quite fit the melody we thought we knew. It's a discord that might be revealing a deeper harmony we haven't learned to hear. It's an echo of something, we're not sure what, bouncing off the walls of our ignorance and returning to us as questions. What if Is-2 is the first of many such echoes? What if the universe is full of things that don't quite fit, objects and phenomena that challenge our understanding? What if mystery isn't the exception but the rule? What if the universe isn't just stranger than we imagine, but stranger than we can imagine? The echo of Is-2 is also a call to humility. We've made such progress in understanding the cosmos. We can measure the age of the universe, map the cosmic web, detect gravitational waves, image black holes. But Is-2 reminds us that we're still children playing on the beach, while the ocean of truth lies undiscovered before us. As I sit here, talking into the darkness about a dark object disappearing into darkness, I'm struck by the poetry of it all. Is-2 is like a koan, those Zen riddles that have no logical answer but lead to enlightenment through contemplation. What is the sound of one hand clapping? What was your face before you were born? What is Is-2? The answer might not matter as much as the asking. The echo might be more important than the original sound. The mystery might be more valuable than any solution, because it's in the unknown that we find room to grow, to imagine, to become more than we are. Is-2 is leaving us, but its echo will remain. In our data, in our theories, in our dreams, in our questions. Every time we look at the night sky, we'll wonder what else is out there, passing through, carrying secrets we can't decode. Every time we think we understand the universe, we'll remember Is-2 and its refusal to fit our models. Part 9. The Next Visitor. It's going to happen again. Maybe not tomorrow, maybe not next year, but soon on a cosmic timescale. Another object from another star system will pass through ours, and when it does, we'll be ready, or at least we'll be more ready than we were for IS-2. The preparations have already begun. Telescopes around the world are being upgraded with new software, new sensors, new search protocols, specifically designed to catch interstellar visitors early. The Vera Rubin Observatory, with its enormous field of view and unprecedented sensitivity, will scan the entire visible sky every few nights. It will catalog billions of objects, track millions of asteroids, and hidden among them, it will find the next IS-2. When that discovery comes, and it will come, we'll have learned from our experience with IS-2. Response teams are being organized. Observation protocols are being refined. Rapid response missions are being designed. The next visitor won't catch us quite so unprepared. But will we understand it any better? That's the question that keeps astronomers awake at night. Because if the next visitor is as strange as IS-2, if it has its own unique set of anomalies and impossibilities, then we might be facing a pattern we don't understand. Not just individual mysteries, but a whole category of mystery, a type of object that doesn't fit any framework we have. Some researchers are already preparing for this possibility. They're developing new theories about what kinds of objects might exist in interstellar space. Fragments of destroyed planets, ejected moons, rogue comets that have been traveling since the galaxy was young. Each would have its own signature, its own properties, its own story to tell. There's also the technological preparation, plans for interceptor missions that could be launched quickly when the next visitor is detected. Designs for probes that could match velocity with an interstellar object, study it up close, maybe even land on it. The technology is challenging but not impossible. It just requires will, funding, and time. The next visitor might be detected tomorrow. As you listen to this, automated systems are scanning the sky, comparing tonight's images with last night's, looking for anything that moved too fast or came from the wrong direction. Somewhere in that data, there might already be another IS-2 waiting to be discovered. Or it might be years before we see another one. The galaxy doesn't run on our schedule. Interstellar visitors come when they come, following orbits that were set in motion before Earth existed. We can watch, we can wait, we can prepare, but we can't control when or what shows up. When the next visitor does arrive, it will tell us something important about IS-2. If it's similar, with the same strange properties and unexplained behaviors, then we'll know IS-2 wasn't unique. There's a class of objects out there that we don't understand. If it's different, with its own set of mysteries, then the problem is even bigger. The universe might be full of things that don't fit our models. The public reaction to the next visitor will be interesting to watch. IS-2 has prepared us psychologically for the idea that interstellar objects exist and can be weird. The next one won't be as shocking, but it might be more exciting, especially if we can study it better, especially if it's even stranger than IS-2. There's already speculation about what the next visitor might be. Some hope for an obviously artificial object, something that settles the question once and for all. Others hope for something natural but exotic, a piece of a neutron star or a chunk of dark matter. Still others hope for something comprehensible, an ordinary asteroid that just happens to be from another star system. But the universe rarely gives us what we hope for. It gives us what is, and we have to deal with it. The next visitor will probably be neither obviously artificial nor completely natural. It will probably be another mystery, another question mark, another reminder that we don't understand as much as we think we do. The infrastructure being built to detect and study the next visitor will have benefits beyond interstellar objects. The same systems that can spot IS-2-like objects can also detect potentially hazardous asteroids, track space debris, and monitor changes in known objects. The investment in watching for interstellar visitors is also an investment in planetary defense and space awareness. There's also the international cooperation aspect. IS-2 showed that studying interstellar visitors requires global collaboration. No single country has all the telescopes, all the expertise, all the resources needed. The next visitor will be a world effort, a reminder that some challenges are bigger than borders. The next visitor might stay longer. If we detect it earlier, on its way in rather than its way out, we might have years to study it. We could watch it approach, brighten, pass by the sun, and recede. We could see how it behaves in different parts of the solar system, how it responds to solar radiation, whether it shows any signs of activity. Or the next visitor might be faster, passing through so quickly we barely have time to point our telescopes. It might be smaller, harder to detect, harder to track. It might be darker, reflecting less light, hiding its secrets in shadow. Each visitor will present its own challenges, its own opportunities, its own lessons. The psychological impact of knowing another visitor is coming, even if we don't know when, is profound. We're no longer alone in our solar system. We're a bus stop on an interstellar route we don't understand. Objects pass through regularly, carrying stories from elsewhere, reminding us that our neighborhood is part of a much larger community. This knowledge changes how we think about our future. If objects can travel between star systems, so can we. Eventually, if IS-2 survived its journey, so might our probes, our messages, maybe even our species. The next visitor isn't just a scientific opportunity, it's a proof of concept for interstellar travel. Some researchers are proposing that we should be preparing not just to study the next visitor, but to use it. If an interstellar object passes close enough, we might be able to land equipment on it, turning it into a free ride to another star system. It would be a slow journey, millions of years, but it would be free, using the object's existing momentum. The next visitor might also bring risks. Most interstellar objects will pass harmlessly through, but what if one is on a collision course with Earth or another planet? The odds are tiny, but not zero. Preparing to study interstellar visitors is also preparing to defend against them if necessary. There's also the contamination question. If interstellar objects can carry organic material, they could also carry contamination. Not life necessarily, but chemicals or compounds that could affect our environment. The next visitor will need to be studied carefully, not just for what it might teach us, but for what it might bring with it. The cultural preparation for the next visitor is as important as the scientific preparation. Science fiction is already imagining scenarios. Artists are creating visions of what might come next. Musicians are composing soundtracks for future encounters. We're preparing not just our instruments, but our imaginations. The next visitor might be the one that changes everything. The one that's obviously artificial. The one that responds to our signals. The one that carries a message we can decode. Or it might be just another mystery, another question to add to our growing collection. Either way, it will be a reminder that the universe is still capable of surprising us. As we wait for the next visitor, IS-2 continues its journey. Every second, it moves farther away. Every moment, it becomes a little more lost to us. But it's also opened a door that can't be closed. We now know that interstellar visitors are real, that they pass through our solar system, that we can detect them. The next visitor is out there, somewhere, approaching or already here but undetected. It might be huge or tiny, fast or slow, artificial or natural. It might answer all our questions about IS-2 or raise entirely new ones, but whatever it is, we'll be watching, because now we know to look. Part 10. The Great Silence. Space is loud with silence, not the absence of sound, but the presence of questions that echo without answer. IS-2 has added its voice to this silence. Another mystery in a universe that seems determined to keep its secrets. And as it fades from our view, we're left to contemplate what its silence means, not just about IS-2, but about everything we don't know. SETI, the search for extraterrestrial intelligence, has been listening to the cosmos for over 60 years. Radio telescopes pointed at promising stars, scanning frequencies where intelligent signals might hide. Optical telescopes looking for laser pulses, deliberate flashes that nature wouldn't produce. And in all that time, through all that listening, we've heard nothing, or at least nothing we can confirm as artificial. This is the Great Silence, also called the Fermi Paradox. If the universe is vast and old, if stars and planets are common, if life arises naturally from chemistry, then where is everybody? Why don't we hear them? Why don't we see them? Why in a galaxy that should be teeming with intelligence, do we appear to be alone? IS-2 makes this silence even more puzzling, because now we know that objects can travel between star systems. We know that visitors can arrive unannounced. We know that the galaxy is more connected than we thought, and yet still, silence. IS-2 came and went without a word, without a signal, without any clear evidence that intelligence was involved in its journey. But what if the silence itself is the message? What if IS-2 and objects like it are how civilizations communicate across the vast distances of space? Not with radio waves that weaken and scatter, but with physical objects that carry information across millions of years. What if we're surrounded by messages we don't know how to read? Consider the challenge of interstellar communication. Radio signals weaken with distance following an inverse square law. A signal powerful enough to cross interstellar distances would require enormous energy, and it would need to be aimed precisely at a target that might not be listening at the right time or the right frequency. The odds of successful radio communication between stars are discouragingly small. But physical objects are different. They don't weaken with distance. They don't need to be aimed precisely. Orbital mechanics will carry them wherever they're going. They don't need someone to be listening at exactly the right moment. They can wait millions of years to be discovered. If you wanted to send a message that would last, that would travel, that would eventually find someone, you might choose a physical object over a radio wave. Is-2 could be such a message, not necessarily for us, perhaps we're just accidental recipients, but a message nonetheless, encoded in its composition, its structure, its trajectory. We don't know how to read it, but that doesn't mean it's not there. The silence might be our inability to hear what's being said. The great silence has many proposed solutions. Maybe life is rare. Maybe intelligence is rarer. Maybe technological civilizations destroy themselves before they can communicate. Maybe they choose not to communicate. Maybe they're communicating in ways we can't detect. Maybe they're here but hidden. Each explanation has problems, but so does the silence itself. Is-2 adds a new dimension to these proposals. If interstellar objects are common, then civilizations don't need to travel to spread their influence. They can send probes, artifacts, messages in bottles that drift between stars. The galaxy could be full of such objects, each carrying information from its creators, even if those creators are long dead. This leads to a haunting possibility. What if the galaxy is full of dead civilizations? What if intelligence is common but brief? What if every technological species eventually faces some challenge they can't overcome? Climate change, nuclear war, artificial intelligence, or something we haven't imagined? What if IS-2 is from one of these dead civilizations, a tombstone tumbling through space? The silence would make sense then. We're not hearing anyone because there's no one left to hear. The galaxy is a graveyard, and IS-2 is just one of countless relics drifting among the graves. We're not alone in the universe, but we're alone in time, the only civilization currently active in our corner of the galaxy. But there's another possibility, one that's perhaps more unsettling. What if the silence is intentional? What if civilizations that survive learn to be quiet? What if there's something out there, some danger or predator or universal challenge? That makes silence a survival strategy. What if Is-2 is silent, because silence is the only way to survive? This is the dark forest hypothesis. The idea that the galaxy is full of civilizations hiding from each other. In this scenario, revealing yourself is dangerous. Any civilization capable of interstellar communication is also capable of interstellar destruction. So everyone stays quiet, watches, waits, hoping not to be noticed. If Is-2 is artificial, its silence makes sense in this context. No signals, no obvious technology, nothing that screams intelligence. Just an object that could be natural, maintaining plausible deniability as it passes through. A scout that doesn't want to be recognized as a scout. But the silence might also be about comprehension. What if advanced civilizations communicate in ways so far beyond our understanding that we don't recognize it as communication? What if Is-2 is broadcasting constantly, but in gravitational waves, or neutrinos, or quantum entanglement, or something we haven't discovered yet? What if the silence is just our deafness to languages we don't know exist? There's a humbling thought experiment. Imagine trying to explain radio to someone from the Middle Ages, not just the technology, but the concept. Invisible waves, carrying voices across vast distances. It would sound like magic, like impossibility. Now imagine what concepts might be equally impossible to us. What technologies might be as far beyond our current understanding as radio was beyond medieval comprehension. Is-2 might be using such technologies. It might be a beacon, a transmitter, a carrier of information that we simply can't access. The silence might not be silence at all, but a conversation we're not equipped to join. The great silence also raises questions about time. The universe is 13.8 billion years old. Our galaxy is nearly as old. Earth is 4.5 billion years old, but technological civilization on Earth is maybe 200 years old, if we're generous. That's 0.0000044% of Earth's history. If civilizations are typically that brief, the odds of two existing at the same time are vanishingly small. Is two might be from a civilization that died billions of years ago. Its creators might have evolved, thrived, and vanished before our solar system even formed. The silence isn't because we're alone now, but because we're separated by time as much as space. We're looking for contemporaries in a universe where succession is more likely than coexistence. This temporal isolation is perhaps the most profound aspect of the Great Silence. Even if the galaxy produces intelligent civilizations regularly, they might be scattered across time like islands in an ocean, each one alone in its moment, aware that others existed or will exist, but unable to communicate across the vast gulf of years. Is two embodies this temporal isolation. It's a message from the past, carrying information about conditions that no longer exist, from a place that might have changed beyond recognition. Even if we could decode its message perfectly, we'd be reading history, not news. A voice from the dead rather than a conversation with the living. But perhaps that's enough. Perhaps the Great Silence isn't a failure of communication, but a different kind of communication. Not conversation, but archaeology. Not dialogue, but discovery. Each interstellar visitor is an artifact from another time and place, and by studying them, we learn that we're not alone, even if we're alone right now. The silence is also about probability. The Drake equation, which tries to estimate the number of communicating civilizations in the galaxy, has so many unknown variables that it can produce almost any answer. Maybe there are millions of civilizations, or maybe we're the only one. Is 2 doesn't resolve this uncertainty, but it does add new terms to the equation. How many civilizations produce interstellar objects? How many of those objects are detectable? How many carry information? As we refine our understanding of IS-2 and objects like it, we're also refining our understanding of the Great Silence. Each visitor tells us something about what's possible, what's probable, what's out there. The silence might remain, but it becomes a more informed silence, shaped by evidence rather than just speculation. Conclusion: still traveling. And so we come to the end of our time together, though IS-2's journey continues. Right now, as these words fade into the darkness, IS-2 is still out there, still moving, still carrying its mysteries towards some unimaginable future. It doesn't know we exist. It doesn't know we wondered about it, argued about it, dreamed about it. It just continues, indifferent to our curiosity, following the path set for it millions or billions of years ago. By the time you wake tomorrow, IS-2 will be another 2.5 million kilometers farther away. By next week, it will have traveled the distance from Earth to the Moon 60 times over. By next year, if we can still see it at all, it will be a ghost in our largest telescopes, a phantom at the edge of detection, and then it will be gone from our view forever, though it will continue to exist, continue to travel, continue to be. Where will it be in 1,000 years? 10,000? A million? The calculations are simple, but the numbers are staggering. IS-2 will outlive our civilization, our species, probably our planet. When the sun expands and Earth becomes uninhabitable, IS-2 will still be out there, tumbling through the darkness, unchanged by our extinction. There's something both terrifying and comforting about that permanence. Terrifying, because it reminds us how brief we are, how small, how insignificant in the vast machinery of the cosmos. Comforting because it means something survives, something continues, even if it's just a mysterious rock carrying questions we couldn't answer. IS-2 has changed us, though it doesn't know it. It's changed how we think about our solar system, no longer isolated, but connected to the galaxy through these wandering visitors. It's changed how we think about interstellar space, not empty but populated with objects we're only beginning to detect. It's changed how we think about ourselves, not unique observers but one of perhaps many who've watched similar objects pass by. The questions IS-2 raised will outlive its visibility. What was it? Where did it come from? Why did it behave the way it did? Was it natural or artificial? Was it unique or common? These questions will drive research for years, decades, maybe longer. Graduate students not yet born will write dissertations about IS-2. Telescopes, not yet built, will search for objects like it. Missions not yet imagined will be designed to intercept the next one. But beyond the scientific questions, IS-2 leaves us with philosophical ones. What does it mean that we can detect mysteries we can't solve? What does it say about the universe that it sends us visitors we don't understand? What does it tell us about knowledge itself? That sometimes the more we learn, the less we know. Is-2 also leaves us with a choice. We can let it fade into history, another unexplained anomaly in a universe full of them, or we can use it as motivation, as a reminder that there's still so much to discover, so much to understand, so much to explore. We can let Is-2's mystery inspire us to build better telescopes, develop new theories, ask bolder questions. We can let it push us toward a future where the next Is-2 doesn't leave us quite so puzzled. The legacy of Is-2 might not be in what it was, but in what it makes us become. If it pushes us to look more carefully at the sky, to take interstellar visitors seriously, to prepare for the next encounter, then Is-2 will have changed the course of human knowledge, even if we never learn what it actually was. There's also the personal legacy, the way Is-2 has touched individual lives, the astronomers who've spent sleepless nights observing it, the theorists who've wrestled with its impossibilities, the artists who've been inspired by its journey, the children who've looked up at the night sky with new wonder, knowing that visitors from other stars are real. Each person touched by Is-2 carries a piece of its story forward. And you, listening to this in the darkness, you're part of that legacy too. You've spent these hours thinking about something most people will never know existed. You've traveled with Is-2 in your imagination, followed its path through the void, wondered about its origins and purpose. In a small but real way, you've made Is-2 matter. You've turned a distant, silent object into a story, a question, a meditation on our place in the universe. That transformation, from object to meaning, is perhaps the most human thing we do. We take the raw material of existence, the rocks and light and motion, and we weave them into narratives that help us understand ourselves. Is-2 is just the latest chapter in that eternal story, the one where humans look at the unknown and ask what if. As Is-2 continues its journey, it carries with it an invisible cargo, all our questions, all our wonder, all our attempts to understand. They don't physically travel with it, of course, but in a sense, Is-2 is now more than just rock and ice and mystery. It's become part of human consciousness, a symbol of the unknown that surrounds us. Somewhere out there, perhaps, another civilization is watching their own Is-2, asking their own questions, feeling their own mixture of awe and frustration. Maybe it's the same Is-2, seen from a different angle, at a different time. Maybe they understand it better than we do. Or maybe they're even more puzzled. Maybe they've sent probes to intercept it. Or maybe they've just watched it pass, as we have. The thought that Is-2 might connect us to other watchers, other wanderers, is both thrilling and melancholy. Thrilling because it suggests we're not alone in our curiosity. Melancholy because we'll never meet these other watchers, never compare notes, never share what we've learned. We're like ships passing in the night, aware of each other's lights but unable to communicate. But perhaps that's enough. Perhaps knowing that others might be watching, might be wondering, might be feeling the same cosmic vertigo we feel. Perhaps that knowledge itself is a kind of communion, not direct, not verbal, but real nonetheless. A shared experience separated by unimaginable distances, but united by common questions. Is-2 reminds us that the universe doesn't owe us closure. Not every story has an ending. Not every question has an answer. Sometimes things just are, mysterious and unexplained, and we have to find a way to live with that uncertainty. It's uncomfortable, but it's also honest. It's how the universe actually works, full of phenomena that don't fit neatly into our categories. In years to come, when Is-2 is just a memory in our databases, new interstellar visitors will arrive. Each one will bring its own mysteries, its own challenges to our understanding. Some might be easier to explain than Is-2, others might be even stranger, but each will be a reminder that our solar system is not a closed system, but part of a vast, interconnected galaxy, where objects, and perhaps information, flow between stars. We'll get better at detecting them. Our instruments will improve, our response times will quicken, our theories will evolve. Maybe someday we'll even catch one, land on it, sample it, finally answer the questions that Is-2 raised. But even then, new questions will arise. The universe is generous with its mysteries. As you drift towards sleep tonight, perhaps you'll think of Is-2, still out there, still traveling, through darkness we can't imagine, toward destinations we'll never know, carrying secrets we couldn't decode. It's a lonely image, but also a profound one. A reminder that existence doesn't require understanding, that the universe continues whether we comprehend it or not. IS-2 doesn't care that we've watched it, studied it, wondered about it. It has no opinion about our theories, no response to our questions. It simply is, and it simply goes, following the deep laws of motion that govern everything from atoms to galaxies. In its indifference is a kind of purity, an existence unmarred by meaning, purpose, or doubt. But we're different. We can't help but seek meaning, even where none might exist. We can't help but tell stories, even about silent rocks in space. We can't help but wonder, even when wondering brings no answers. That's our gift and our curse, to be conscious in a universe that might not be, to ask questions of a cosmos that maintains its silence. IS-2 is leaving us, but it's also left something behind, a change in how we see our place in the universe, a new category of object to study and wonder about, a reminder that discovery isn't over, that surprise is still possible, that the universe still has cards it hasn't played. Most of all, IS-2 has left us with a story, not a complete story, not a satisfying story, but a true story, a story about something real that happened, something we witnessed but couldn't explain, a story that will be told and retold, each time with new theories, new possibilities, new questions, a story that connects us to the cosmos in a way that only mysteries can. The night is deep now, and perhaps you're feeling the pull of sleep. As you drift off, know that IS-2 continues its journey, indifferent to our dreams, but somehow part of them. It travels through the same darkness that surrounds us all, the darkness between stars, between thoughts, between heartbeats. Tomorrow the sun will rise, and the familiar world will reassert itself. But tonight, for these few hours, you've been somewhere else. You've traveled with IS-2 through impossible distances, contemplated impossible questions, touched the edge of the impossible universe we actually live in. And that journey, that wondering, that willingness to sit with mystery rather than demanding answers, that's perhaps the most important thing IS-2 has given us. Not knowledge, but wonder, not answers, but better questions. Not certainty, but a more honest uncertainty. IS-2 is still traveling, and in a way, so are we, through a universe we don't fully understand, toward futures we can't predict, carrying questions that might never be answered. But we're not traveling alone. We have each other, we have our curiosity, and we have the memory of IS-2, that strange visitor that came from nowhere, showed us wonders we couldn't explain, and disappeared back into the nowhere from which it came. Sleep well, fellow traveler. Dream of distant stars and impossible objects. Dream of mysteries that refuse to be solved. Dream of a universe vast enough to contain IS-2 and us and countless wonders we haven't yet imagined. And when you wake, remember that somewhere out there, beyond the blue of our sky, beyond the reach of our telescopes, beyond the edge of our understanding, IS-2 continues its eternal journey, silent, mysterious, alone, but somehow carrying all our questions with it into the cosmic dark. The universe is vast, and we are small, but we are the part of the universe that wonders about itself. We are the cosmos awakening to its own mystery, and IS-2, in its silent passage, has reminded us of that profound responsibility and privilege. Thank you for joining me on this journey into the unknown. Thank you for sitting with mystery, for embracing uncertainty, for wondering about things that might never be explained. The night is full of questions, and though we might never find all the answers, the asking itself is what makes us human. IS-2 is still traveling, through darkness, through silence, through time itself, and somewhere perhaps, another civilization is watching it approach, preparing their own telescopes, their own questions, their own wonder. The story continues, even as our part in it ends. The mystery deepens, even as we close our eyes. The universe expands, carrying IS-2 and all its secrets ever farther into the beautiful, terrible, infinite unknown. Good night, and may your dreams be filled with interstellar wonders.